Good afternoon or good evening. Greetings of the day wherever you're dialing in from. I'm Divik, the past chair of BTSym, and today I've got the pleasure to welcome you to yet again joint lecture that we have lined up for the day. I have lost track of the countless joint lectures the BTSym and TAIym have delivered over the course of past 2 years. But I'm quite thankful to TAIym for sort of carrying on this continued collaboration with us. And today, it also gives me the pleasure to welcome the current chair of TAIym, Ayush, to introduce our two speakers for the day. So over to you, Ayush.
Courses of Indian Army and has his masters in rock mechanics and underground structures. He has been instrumental in monitoring the tunneling projects in high altitude, almost 10,000 feet above sea level, under inclement weather and cold climatic condition. Presently, he is looking after Atal Tunnel and also involved in preparation of DPRs of various projects. Uh, Next, I would like to welcome Mr. Sandeep Nirmal, uh, an active member of not only TAIym but also ITAYM, BTS, YM. He is the past chair of TAIym and finalist of ITA Young Tunnel Award. He holds a master degree in tunneling and underground space. He was involved in various projects like Crossrails, Thames Tideway, Mumbai Metro, Delhi Metro, etc. Presently with Rites, he is currently involved with design of about more than 80 tunnels in India and in international projects. I would also like to welcome Mr. Ahmed Shaz, an active member of TAIym, who has his master's degree in rock mechanics and underground structure. After designing various metro tunnels, he is presently associated with Rites and involved in various high-altitude tunnel passes in Ladakh and other Himalayan areas. So, welcome you guys. And now I would like to hand over it to Sandeep and Lieutenant Colonel Sunny and Ahmed Shaz for this wonderful presentation.
Okay, thank you, Ayush. After that detailed introduction, I would mention that it's really great to be here and to share a platform with TAIym and BTSym. Thank you guys for all that. Without now, I'll directly come to the presentation. It's pertinent to mention that we take immense pride in presenting today in front of this August gathering. Without further ado, I'll start with the presentation. Coming down to the Chinkula Tunnel project, it's a national strategic project which will provide round-the-year connectivity to far-flung areas of our country, as I am from India, and representing Border Roads Organization, which is putting all-out efforts in a mission mode to complete this project. And equal efforts are being put by Rites with a joint venture with GeoConsult in achieving the, I would say, target by providing the draft project report well in advance at this time so that all the targets are met. Now, I'll request Mr. Ahmed Shaz to continue with this part.
Yeah, thank you. Thank you so much, Sunny sir. Sandeep, can we go to the next slide? Yeah, my name is Ahmed Shaz. I'm part of Rites Limited, and we are working on Shinkula Tunnel project. We are making DPR on that. Apart from Shinkulla, there are many other DPR projects that are coming to the high altitude of Himalayan terrains. And this is one of the projects for which we had recently submitted the DPR that is still in the approval stage. There are many constraints. We cannot go into the minute details of the project considering the strategic nature and the stage in which it is right now. So going to the next slide, we can have a discussion regarding the experience what we had shared in completing the DPR in a very difficult area, very remote area, an area where we have only 4 to 5 years of months of effective working season, working period in a whole year, and we have to complete all the activities that are required to prepare a quality DPR in this particular time only. Uh, so Sandeep, can we move to the next slide? Sandeep, can we go to the next slide?
Yeah, Shaz, is this visible to you? Because we have moved to the next slide already.
No, sorry, it is not visible to me. But it is from my end only, or everybody can see. Only I'm not able to see the next slide.
I'll try to do that again. Just give me a second.
Yeah.
I'll try to share it again.
All right.
holes crossing more than 1,000 meters of drilling in that area. Then AEM survey was done with Chinook, and Chinook was like the one of the best helicopter possible in that area. And AEM survey is usually done when the area, and especially in the difficult type of terrain, when some of the portion is not accessible. So it's a very recent technology, and the helicopters they used to come for around 500 kilometers just to have a movement on the alignment, and you can get as deep as 600 to 700 meters of geological data when that helicopter is moving with the antenna just above 50 meters from the ground surface. So, yeah. Hello. Yeah. Means only I have to start, or Colonel Sunny have to start again? Okay, now my voice is clear. Okay, hi everybody. So this project, what Colonel Jasani sometime before just had given a brief about it. It's a 4 kilometer road project in the central Himalayas with twin tube tunnel, and there are cross passages connecting both the tubes. The altitude of the portal around 4,800 meters, and the passes on which we were working in that area around 5,100 to 5,300. Some of the tunnels which we're working is like the highest motorable road in the world, and we are making tunnels in that. So coming back to our this project, the height of the pass was 5061. Okay, again something happened. Hello. I'm audible, but I'm not able to see the presentation. Sandeep, there's some issues from your side.
Is it same for you, Divik? Let me share
But
again.
I'm uh, 300 meters, and the site accessibility is 3 to 4 months effectively. And in that 3 to 4 months, you have to tackle a lot of difficulties, and there are frequent snowfall, rainfall, and then sometimes cloudburst. And the approach road which will lead you to the tunnel site area sometimes got washed away in that working month of 3.5 months. So a lot of challenges we have to face on a daily basis. And this tunnel, once it is made, will shorten the distance from Manali to Leh by around 30 kilometers, and from Manali to Kargil for around 100 kilometers. It is a twin tube tunnel with the unidirectional traffic. So this is a project of high strategic importance, and the construction tender under process. And can we go to the next slide? Okay, to prepare the quality DPR, we did many pre-construction studies in the site area. Some of the studies I listed down. These are traffic studies that was carried out, and then alignment design was done. There were many options what we had figured out, and out of that all the alignments, we had selected the best possible one in that area, considering all the constraints, all the mandates. And we had procured high resolution satellite imagery, and after that topographic survey was carried out. And for geological thing, investigation. We did geological mapping. Our whole team of geologists, senior geologists, and all everybody that just went through the alignment in the remotest possible area, even on the maximum burden, and they did a good job. And after that, the boreholes were planned, and we did extensive drilling program was carried out, so that all the boreholes that were required can be completed in the limited time. And we did more than sufficient drilling, working day and night in that area. Although it is very difficult to work at night, but somehow we managed. And the geophysical survey was done by three methods. ERT, SRT was carried out physically on ground. And after that, AEM survey was also carried out. AEM survey is basically airborne electromagnetic survey that was carried out through an antenna that is basically handled by a helicopter. We used Chinook helicopter, and these antenna was just taken along the alignment, and you can get as deep as 600 to 700 meters of geological data inside the ground. But the only constraint is you have to maintain the distance between the antenna to the ground for around 50 meters. If the distance between antenna and ground will increase, the penetration depth will also increase accordingly. So, apart from that, we did environmental impact assessment and social impact assessment, all the areas. Although there are very little settlement nearby, some villages are having as much as two houses only, and all the villages are like separated by 15-20 kilometers of only trace cut. There is no metal road also in that area, and but still we saw that how they are surviving in that area, and what benefits could this project bring to them. Environmental impact assessment was also carried out, and the report was submitted. Can we go to the another slide, Sandeep? So after the extensive geological investigation, what we did in the area, we had identified around 6 ground types consisting of quartzite, then philitic quartzite, quartzitic phyllite, and upon that 6 ground types, and considering the overburden, around 8 type of behavior types were concluded for the design. And correspondingly, the excavation and support class are designed. So since it is still in tender process, I cannot go deep into the detailed aspect of each thing. This is just a broad thing what we had encountered. The L profile is just, you can see in the presentation, some red lines. These are the shear zones that are encountered just in the middle of the alignment. And we have taken we have proposed suitable measures that need to be taken during construction in that particular area. Deep, can we go to the next slide? So this is a cross section, typical cross section of the twin tubes that are being connected with a cross passage, and much to say in this, not much to say in this. This is just a typical cross section. Site conditions. Site condition, you can see this is June 2020 when we were there on a recce visit. And June in India, if you are listening from India, you can imagine how hot June is. It is April and heat waves are all along India, especially in the northern and southern part, central and southern part. But in June, when we were standing on Shimpulla, it was totally frozen, and we were not able to go to the other side of the pass with our vehicles. It was totally frozen. Snow cover was high, and our vehicle was not able to pass. And it was a good experience. I talk down the line that what experience we had faced when we were there at the site for the first time. Now working in that area for around 2.5 years. It's been almost 3 years since I 2.5 years when I was working in that area. Now body is acclimatized, some better part, lot of hemoglobin. And Sandeep, can we move on to the next slide? So Sandeep, can you just play this video? This is one of the site visit what we had went to. This is also in June, and you can imagine what type of cold and snow and difficult part of the world we are living in, we're working in. And the road was not accessible, especially in that part. We had to trek to the site area just to get the location of the boreholes and portals and the alignment. So now, just I want to share some of the experiences what we had faced while working in that area for more than 22 years. So the working period is very limited. It is around 4 to 5 months. Shinkulla snow cover is high. Some of the other places, some passes, snow cover is less, but temperature is very low. Winds are like biting condition. You cannot stand after 4 on the side after 4:30 o'clock. And since the altitude is very high, it is around 5,000 meters. So you need to acclimatize. The air pressure is very low in that area, so you cannot just come from the plane and stand in that area without getting acclimatized. It will just it will collapse. In fact, many of our colleagues who hadn't gone into a complete acclimatization process, they came to the site and they just uh, felt very unhealthy in that time. And we had to immediately provide them with oxygen cylinders, and then immediately some of the people they were immediately rushed to a safer place. And frequent snowfall and rainfall. When I'm telling you that only 4 months of working, that means rest 8 months they're totally packed. And in that 4 months also there are so many times you will face snowfall and rainfall. But since you have to complete the work, otherwise it is again after 8 months, then you have to do anything to complete it, whether it is snowfall, whether it is the rainfall, whether it is cloud burst, whether it is anything. You have to just focus on the activities and how it will be completed in the limited time. Accumulated snow is very high. Only 3 months you will get when the snow, especially on the road and the nearby area, is less. But it's still at that time also the peaks are all totally frozen. Glacier bound area nearby. Temperatures are very extreme, as I told you. It will go as low as minus 30 degrees in winter time. And even in summers, the maximum temperature what you can expect in the daytime is 10 degree, even less than that. So to tackle all these things, we did a good planning, because you cannot just go and stand that area and started working. So winter clothings, we that's very you can say very costly and very thick. The clothing we had provided to all the workers, irrespective of their categories or designation. Even the laborers, even the supervisors, operators, they were provided with the best quality of winter clothing from our company to work in that area. And icing on the approach road is very common, and icing will lead you to there's a lot of risk of skidding of the side vehicles. Even so, you have to put chains on the tires every time you are moving to the site location, because the roads, once icing is done, icing is had happened on the metal road, and you are taking a turn, you'll just go down what you studied, your all the forces on the horizontal direction, that will just take you away. And the difficult part was there was no cell phone in the area. So once you got stuck, you cannot call anybody. You cannot call for help if you don't have Inmarsat. So we have satellite phone facility, and that actually helped us a lot, not only in the safety and evacuation, but also during breakdowns, during many requirements, logistic requirements, any type of communication, any type of information that need to be checked, that need to be communicated to the design office. So this is Sandeep. Can we go to the next slide? Remoteness is level of remoteness, means you cannot see anything like 50 kilometers south, 50 kilometers north. Some yaks you can see, and even yak will look at you, that who are these creatures coming in our areas. Some horses, wild horses, you can expect So, but apart from human, everything like some very endangered type of species, some wild goats, some even you can encounter a snow leopard also. Especially in the night time, one of our driller, he was sleeping in the tent and he had encountered it. So the very next day, we had shifted whole of the things to a safer place, and this happens generally in the winter time when we are like about to close our site and all the top of the mountains are closed, totally packed, snow capped, and then these wild animals comes to the valley for having a drinking water. So, considering all the remoteness, there is no logistic shop nearby. Some 50 kilometers, you have to buy diesel. One of the petrol pump, it shows you a sign, next petrol pump 375 kilometers ahead. So, just imagine the remoteness that a lack of planning can lead to disaster because you cannot afford lose time in this area. Because once if you are not completed, then again after 8 months, and this is just too much time. So the planning part, especially completing all the activities in a very limited time, is very important, and we did it. For everything, starting with the site mobilization, and then the breakdown of the machine, the supply of logistics, the circulation of informations, and the supply of diesel, uninterrupted supply of man resources, human resources, and everything need to be planned. Some of the example I can tell that the market, the closest big market is around, you can say, 150 200 kilometers away, where you can get spare parts of the machine if it has a breakdown. So you cannot afford to send a team from the site location to that area and then that machine will rectify that part and then come back again. You cannot afford that. So once one of your team will be sitting at that marketplace, and one message they got that okay, this part is failing, immediately they will purchase it and will send it back to the site. So within a minimum time you will get it repaired. This is how it is. Then again, because the area was very difficult, many a time it happens that people used to get stuck in the snowfall. So our one of our team, they used to be ready at every by around 8 8:30 9 o'clock, and they used to wait whether all the people they came back to our guest house, which was there like around 70 80 kilometers south of the project. If they are not there at the guest house by 9 o'clock, then evacuation team was sent immediately to get them or to find them or to see whether what problems they are facing. And many of our brave fellas, they started staying on the site in spite of the extremely harsh condition just to meet the deadlines. And that was when the site was about to close. Wild animals risk was definitely there. Oxygen was very low. Temperature was very low, and pressure was very low. So all combined low things got together, and since oxygen was low, you'll feel difficulty in breathing. And by the time we were working in this area, it was COVID in a COVID scenario. So many times you get confused. Okay, whether it is due to lack of oxygen or whether you got affected with COVID. So this type of dilemma every time it used to come with everybody who's working on that area. So you have to pump some oxygen on a daily basis. You have to provide big safety measures, and this is how it is done. Uh, Going to the next slide, these are the logistic issues what we have faced. Now coming to the technical challenges, the area was not accessible when the main approach road itself was under construction when it started working that area. So to send our machine to a location good for drilling, we many a time we have to make approach roads, and these approach roads are sometimes as long as 4 kilometers 3 kilometers for some of the projects. Shinkulla, fortunately, not that much approach road was required, but still if you accumulate add all the approach roads, was around more than a kilometer of approach road, or even more than that what we had made just to drag our machines, heavy machines, all the equipments to the drilling locations and start drilling to the right place. So trace cut was difficult. You have to keep working, making up platforms, And these are time taking, time consuming activities. Many a times your trace cuts nicely built, after some snowfall, some rainfall, they got washed away, and again you have to do rework in that area. So rework is a very natural, very a common thing. Everybody in the team are like peace with the rework in that area. Everybody knows that rework is a very natural thing. You have to do it. Machine efficiency is also a very important
I'll just ask Shaz. Maybe he's not connected. Or Derek, do you want me to continue until he joins? Let me know when I can go ahead with 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 the presentation. Uh, well, Shaz was the best person to describe all his experiences which he had on the site for these pre-construction studies. But I think he's actually on site right now, and the network is usually not very good. Probably he's just cut off. I'm hoping to tell his story through his own words, and he joins us back again. Until then, I'll just carry on. Uh, so when we were doing pre-construction work on the site, as Shaz has already told, that not just uh, not just doing the work, but to enable uh, for workers to do it and to make all the arrangements for the machinery and the logistics to be there for doing that work was a big challenge in itself. So if we can see that every day when we came to site in the morning, so we had to travel about 50 to 60 kilometers one way, and which was the nearest, uh, which was the nearest town.
Sandeep, can I start?
Yeah, Shaz, you're back. Yes, please go ahead. Go ahead.
Sorry, I didn't. I don't know what had happened.
I was just sharing that how reaching the site every day was difficult, and how when every day when we came to the site, we found frozen water, and just to start working, it was very difficult to melt it first and then start working every day. It was a process for. So you can go ahead and tell your story yourself.
Yeah. So I was telling about low machine efficiency. So we were actually working with 60% of efficiency. So you can expect that for that reduced 40%, we had to put our effort more than 40% to just balance the progress. And the high wear and tear was very high because of n number of reasons, and the same thing that we had to ready our team at this market location, so that the wear and tear thing could be repaired as soon as possible. Our satellite phone had worked a lot in this. Freezing of diesel, just imagine, was a very common phenomena, especially when we are close to completing our site. So we used to procure some diesel capsules that we used to put in the diesels, and because of that, the diesel never freeze. If you don't have these capsules, then what Sandeep was telling, again, every morning your day start with putting some fire below the machine, so that all the frozen diesel that will melt away, and you can start with the progress, and that will just consume 1.5 hours of a very comfortable morning of yours, because after 4 or 3 or sometimes 3 o'clock you have to stand on the site. It's chilling cold, especially when after October, even after mid September, you can say. Non-availability of water for working is also a big issue. You can see the photographs, all the pits, all the these tanks in which we used to store water, they all just get frozen. You need to have some source of water. If you don't have, then the only option is you have to fill tankers from a place which is at a lower altitude, even it let it be some 50, 60, 70 kilometers away, but you have to fill it, and then you have to take that tanker on a daily basis to your site. So fortunately in Shunkula we have some streams, but in October when we were working, these streams all got frozen. The pits, the tanks all got frozen. So that was very difficult to work. In other projects, we are using tankers from day one because there are no water channels on the top of the mountains. So going to the next slide. These are some of the a few technical challenges what I just shared with you. But our team, like every single day, there is some big thing that happened on the site. For example, some one day it happened that whole cloud burst happened, and whole of the main road that got washed away. So like a whole team who were there in the guest house, they remain in the guest house. Who were there at the site, they have to take a different guest house for till the time that road was under repairing. So uh, then again, some health issues keep on happening to the people who are working. Very common phenomena is nausea, some breathlessness, and especially when you're working in that high altitude and you have to lift something, you have to put some physical effort on some activity. You cannot imagine what will happen to you. You will just breathlessness, suffer breathlessness to the maximum possible limits. And going to the next slide. So these are some of the photographs of the site. Many of times your vehicle will not able to reach the site location, and believe me, at that height of 5,000-meter altitude, you have to trek literally for around kilometers. Means as much as 10 kilometers you have to go, and 10 kilometers you have to come back, crossing all the water steam, having water as cold as ice. You cannot put your foot in that cold water for more than 30 seconds, but you have to because there's no other option, and you have to get into it and then come out. So these type of things. Then evacuation, mobilization, sometimes it is good because you are mobilizing it when the snow is like about to go, but demobilization itself is a big challenge because you have to finish the work and you have to ensure that all your machineries, all your equipments, all your resources, they are safely back to the comparatively lower elevation in the time when the area is not packed. Colonel Sunny can understand the difficulty of this area. Some of the people got stuck also in the and like Colonel Sunny and his team, they had helped us a lot in getting that people out of the very difficult situation, and with the help of whole administration, and we totally obliged to them. It was around 2 in the night. Yeah.
Absolutely.
Then going to the next slide. These are some of the pics when this cloud burst happened. This type of scenario you can imagine. This is the main road, main highway on which this JCB is standing. And just imagine if the condition of highway is that, what will happen to our trace cut. That is मतलब कि with the time t is equals to 0, it is in perfect condition. So just imagine when this type of things are happening. So how difficult it is to for the site team to move to the site and do their regular activities. And many a times you go to the site and whole night it was raining and snowfall, and most of the equipments, everything will be submerged in snow, and then you have to identify that okay, where is our machine. Then you will wait for the sun to come up, or you have to physically remove all the snow and then again start the activities. One of the photos in night, you can see that is our demobilization process that is going on. We were intimated by this department, meteorological department, that just next day snowfall will happen to the site. Snowfall will give you three warnings. One will happen in September or October, second mid-October, and third like November starting. And after third warning, it will be closed totally. and the next time it will open, it will be like 7-8 months gone. So we got last warning that please remove all your machine and all everything. Otherwise, tomorrow snowfall is going to happen, and all your machines will be submerged under big 5 to 10 meters of snow for this whole season. So day and night we worked, and just we got all the machines out from this site area. And exactly what happened, next day snowfall happened and everything got packed. But all our machines, everything got evacuated in the right possible time. This time when we were evacuating, it was around 10 o'clock in the night, what I remember. And the temperature, if I remember, it was below -25. It was chilling cold in that area. And it was 15th of November 2020. So, but still we got all our things evacuated. So, going to the next slide. These are some of the pics of the AIym survey what we had carried out in one of the project. This Chinook helicopter what we had hired, and this helicopter used to take our antenna throughout the alignment. These some alignments, these are like very difficult to access. The over buttons are more than a kilometer high, and physically it is not possible for any person to go and climb these high altitude mountains and do any type of survey, whether it is drilling, whether it is ERT, SRT, geophysical survey. Only option you are left with is AIym survey. And it's difficult thing, but somehow it is done. It has also been done in many of our projects. Some of the pics right now shows our tents at the site location, some drilling, live drilling happening on the site, and the prevailing site conditions in which for you it might be difficult, but when you are working on a daily basis in that area, it is a new normal to you. You feel like, okay, today you can see a bit of sky, clear sky, so everything is good. Because seeing clear sky, especially in Shikula type of area, is a rare phenomenon. There are always clouds. There are always some uh, clouds either are there or they are seems to come or they are coming. But like it is always come wali condition. So going to the next slide. Yeah. So skating, we had also hired some snow scooters also. At there was a time came when our site vehicles were not able to go to the site locations, and our trace cut was around 7 to 8 kilometers long. So it was very difficult, especially when you have a very limited squeezed out time of around 4 to 5 hours per day of working, and a team is like taking 1 hour of moving and 1 hour coming back. So you cannot afford that, because for 3 hours your progress will be like minimal. So we had hired some snow scooters to tackle the thing, to tackle the icing thing, and then take all your team to the site location and continue the process. Some happy moments when all your efforts paid and you get a core as long as 3 meters. So all your efforts, whatever you are putting in, that just you cannot imagine what type of happiness a person from down from the very lowest to the topmost level, how happy they feel when all your effort, all your you can say difficult efforts paid off. So now I will give the presentation to Sandeep, and he will take you forward with some challenges expected during construction. Thank you.
Thank you, Shaz. Thank you for this wonderful experience that you have shared, what you went through by being there on site, by doing all these activities, and uh, while providing for all the workers a very good environment where they can work uh, in such a difficult situation where you are really cut off from the whole of the world.
Sandeep, you might like to check your mic. You're on mute if I'm not wrong.
I'm fine. I'm not mute. Am I audible to you?
I can, yeah, I
Oh,
can.
fine,
Yeah.
fine.
Yeah.
That's, that's, that's perfectly. Fine. Okay, fine.
Yeah. Is it fine? Shall I go ahead?
Yeah.
Okay. Yeah. So I was just thanking Shaz for
Please.
managing all the pre-construction studies and doing all the work on the site to to gather all the information about
Yeah.
this project.
One small thing, Sandeep, if you can just spare me 5 seconds.
Yeah, go ahead, Shaz.
Yeah, just to conclude with a very big thank to the team, to everybody who was part of the pre-construction activities, and they worked literally very hard, just to deliver the quality DPR in the limited time. So my whole task is just a team effort. It's just a team effort, because of which we are able to deliver it. And thank you so much.
Yeah, thanks, Shaz.
Yeah.
That was all the effort that was done was a first step towards the realization of this project. Uh, these tunnels which we are building in extreme condition in Himalayas are very strategic in nature. They have a lot of value in terms of India's defense strategy and connecting the land of Ladakh to the mainland with an easy connectivity throughout the year so that the tourism that is linked to Ladakh uh, can flourish. And definitely, these tunnels have a lot of value in terms of bringing economic development in that area, and and to utilize all the barren space at the moment, and very beautiful space, to be honest, which has huge potential to develop as a big tourism industry. Um, so uh, these tunnels are extreme and have need some specific uh, new ideas to how to do construction in those extreme conditions. So I'll just bring out few of the important aspects from this project. Unfortunately, I won't have time to discuss everything, but few important things that I would like to discuss are, one of the things is concreting in low temperatures. So when the design was going on, the very first question was how the concrete will behave in temperatures like -20, -30 degrees. Um, just to add that the planning for this project is such a way that we have to work 12 months a year. So even if it is -20 degrees, -30 degrees, snowing uh, for a long time with a snow cover of about 5 to 7 or 10 meters at moment, we still have to work. So to enable the contractor and the client, the designers to work for this project to go forward, which is on a very strict timeline, we had to include and consider few technical stuff so that we can foresee these challenges and we can find out ways how to go forward. So since the construction on such a large scale has not been done in such low temperatures, it was very difficult to find uh, the specifications of how the concrete will work in those locations. So we had one of the references from Indian codes, which lays some of the guidelines for that. But to be honest, in such low temperature, these things have not been yet tested. But definitely they will be tested, and there will be a lot more innovations coming out of after this project. So what happens is when the temperature go beyond below 5 degrees, the since the cement and water uh, reaction in concrete is a exothermic reaction, we expect that in lower temperatures the rate of reaction would increase, but that does not happen because water starts to crystallize below these temperatures, and it becomes so cool that it's very difficult for the reaction to go forward. So the guidelines say that the concrete shall always be kept at more than 5 degrees. In no case it should go below 5 degrees. The rapid hardening cements shall be used in the mixed design. Accelerators shall be added. Cement content shall be high. They should never be less than 300 kgs per meter cube. And when we are storing the water and aggregate in those conditions, we know that the concrete will not be able to produce concrete at that low temperatures. So we have to preheat the water and aggregate, and the code says that it should not be heated at any moment. It should not cross 100 degrees. Although for water, the maximum temperature shall be 66 degrees. Uh, the temperature and humidity records have to be maintained throughout the project to ensure that the quality control is in place. We need air entrainment agents into the concrete. In the next slide, I'll show why do we need those. Since this is a location where freezing and thawing um, is very common when you are close to surface. So at least for the first 100 meters of the tunnels, we are expecting that the temperatures will be very low. But when we will be inside, when we're drilling inside the hill, the tunnel will be a little bit warmer due to construction activities and other stuff, and the external temperature not affecting the interior regions that much. So uh, the air entrainment in the concrete is quite important. So if I just go to the next slide, I can show you the graphs that how what happens when the concrete goes through cycles of freezing and thawing. So you can see that as the cycles of freezing and thawing with the concrete increases, the compressive strength can fall to up to 1/8 of what it should achieve, and the falls elasticity in the concrete falls very low, and the concrete can become brittle quite easily, and it can produce cracks. So what happens is we add air entrained agents, so that after entering the air entrained agents, the concrete has some you know scope for recovering from those contractions and still maintain its own properties. Uh, then not just production and not just the components that we add in, but transportation of concrete from the batching plant from production to the site is also an issue. So what we need to do is, as soon as the concrete is ready, we need to put in the concrete into vehicles. We have to put insulation against those surfaces and transport it as soon as possible. So we have to make sure that the concrete shall have the temperature of 10 degrees when it reaches the site of pouring, and the temperature shall not fall below 5 degrees at any cost. Then the concrete mixtures or trucks that are taking the concrete shall be continuously in motion. It should be mixing continuously, and the vehicle should not stop in open or cold temperatures. It should go into the tunnel, and when the temperatures are fine, then we have some time to halt them or to stay inside the tunnel. So what we have planned is we have cross passages. So we'll make some space for the vehicles to stand in the tunnel by the time there are other movements going on parallelly for the construction. So we need a continuous monitoring, a continuous supply chain maintained in with a frame of time, so that there is no excess and no shortage at the same time for the whole project. Then again, we have to make sure that we take all the temperatures and humidity status and make a record of them while we are transporting it to make a decision whether we need to use the concrete or not. So with these graphs, we can have a look at how uh, the um, the concrete behaves at low temperatures. So when we have poured the concrete, and that the graph on the left side, the smaller graph, shows that if freezing occurs around the concrete, the uh, the strength of the concrete reduces to 30 to 50% of what it should achieve in a normally moist concrete. So we have to make sure that the strength of the concrete is not compromised. And then again, if we see that if there are the concrete is continuously on low temperatures for the curing period of concrete. If we are at -7 degrees, if we leave the concrete at -7 degrees temperature, then the strength of the concrete goes to 15% of what it should achieve. So we have to make sure that it's not only production of the concrete or transportation of the concrete, but during placing of the concrete, it is equally important that we place it and we maintain it for the curing period at a particular temperature. So the code provides for the guidelines regarding that as well. It says that we should put the concrete as quickly as possible, and insulation should be provided against the concrete surface, against the shutters, for it to retain the moisture as well as temperature for as long as possible. And since uh, gain the gain in the concrete strength is slower, so we have to make sure that the formwork is longer in position. We have to find out with the mixed designs and the trials that how long they should be. We have to put the formwork a little bit longer so that it gains the strength while we move it. We have to cover the concrete with insulation as soon as the formwork is moved. Uh, Concrete's temperature, as I have already shared, that shall be more than 5 degrees while placing, and it shall be maintained at least for 7 days, preferably for 28 days, but at least for 7 8 days at that temperature. If required, if the temperature suddenly falls, or if we are near the tunnel openings near the surface, then we have to go with the steam heating and to keep it on the temperature that we need. Uh, Although the construction is planned to begin in the summer season. So during summers, these problems may not be as severe as they will be in winters. So the initial portal locations will be casted in place during the summer itself. So but all these factors have to be built in for anything which comes up in future. Concrete shall never be poured against the frozen subgrade or against the formwork covered with snow and ice. Pretty obvious. And obviously the temperature and humidity records have to be taken be kept for throughout the project to maintain the quality of the concrete. And the contractor has to do various trial mixes for finding out the time of demolding, when to do the mixing, what temperatures to do that, how to put it into transportation, what would be the cycle time, how the mixtures will move, and how the concrete will be placed. Then for the short treating, for the short treat, there are many more things that we need to find out during those trial mixes when the contractor is on the site. We need to see how the setting time of concrete changes in those temperatures. How is the bonding with the cold surface? What's the rebound? What's the early setting strength? And we have also kept the option of dry shotcreting. So in case we cannot produce at some time, we cannot produce the wet shotcrete, what we can do is we can store the aggregate water and cement inside the tunnel in the warmer area where the temperature is relatively higher than outside, and then we can do a dry shotcrete where everything is mixed in the novel and is put on the surface itself. And the contractor has to do various mix designs for these shotcretes for sure. It's not only concrete. In those temperatures, maintaining almost everything is very difficult. but apart from concrete, I think the water is also plays a very huge role in this project. What we have seen from the experiences is in this region, if there is a water in the pipe, it just expands and it just breaks the pipe. So it is important that insulation against the pipes shall be provided. Heating systems against the pipe shall be provided with running water so that it doesn't freeze. Vacuum suction facilities should be there so that water and the waste from the pipes can be sucked off so that it does not have the scope of expansion and further degradation and breaking of those pipes and storage drains. And then we need to do regular monitoring and maintenance of those drains so that the uh, water doesn't freeze. Then we need to manage the waste as well, as we know that most of the area during winters is covered with snow. So if we just go and dump everything on the snow, when the snow will melt, everything will go into the valley and it will go flush down the valley and will pollute all the environment there and will produce many issues like groundwater contamination and surface flow contamination. So what we need to do, what we have done is actually we have planned a disposal site where we will put all the muck, all the water which is coming and dump it there. During winters, we'll make sure that it is covered, that it doesn't get filled with snow, and the dumping is carried on until the winters, which is a difficult time. And when the winters are over, we can again rethink about it, how to manage it further, and to prepare for the next season again. So it has to be a continuous thing to go with. uh, then again, ventilation. If we talk about ventilation during construction, so if you think about tunneling and sucking the external air and providing it to the face of the tunnel, then that is not a very good option, because that air outside itself is very cold. So if you put the cold air in, the shotcrete gain strengths, the concrete gaining strengths, and the people who are working in the tunnel will just freeze, and will be very difficult for them to work in that region. So it has to be make sure that we need some heating agents into the ventilation system, so that the air which enters shall be acceptable technically, as well as it provides a good environment, weather conditions inside for the people who are working there. What we can also do is to close the portal of the tunnel temporarily with the air barriers, so that the transfer of air is minimum from the face of the tunnel. So these all aspects have to be taken into account. As Ahmed Shaz has already told, that the experiences that we have had with the pre-construction studies is what we have observed, that the efficiency of all the machines reduces as we go high on the altitude. So as we go higher, the air pressure reduces, and with reduction in air pressure, the air density reduces, which means for every amount of air that the engine brings in for the combustion, sorry, less amount of oxygen is coming in, and hence the proper combustion is not happening. So we what we observed is that we faced about 30 to 40% reduction in the efficiency of machines while working there. So what happens is, generally, for the first 1,000 kilometers above mean sea level, we don't see any reduction in the efficiency of the machines, but every next 1,000 meters we see about 10% reduction. So since we are working at around 4,500, 5,000 meters, we can expect that it is going to be about 40 to 50%. Uh, we have already seen that it was about 30 to 40% for us. So more wear and tear of machine, less use of fuel, uh, and less efficiency of machines has been taken into account. The contractor has to, since this project is going to the contractor's bidding for construction, contractor has to take all these risks into account and quote a price accordingly. We have to maintain few supplies. Whatever we have to use at the site, since roads are almost closed for 6 months. It's very difficult to uh, to maintain a transportation to go to the site and come back. And that's why we need to store important stuff on the site itself, such as cement, steel, aggregate, water, explosives, food for the people, diesel, clothing, so much stuff. Everything has to be planned, and we have to assume that all the workers that will be there on the site have to live there. There should be facilities for that as well. With this, I'll not go too much into the design, because our presentation was about the challenges that we face uniquely at working at those heights. So I'll just briefly speak about what are the primary and secondary supports that we are proposing in tunnel. So we have a combination of shotcrete with rock bolts, wire mesh, lattice girders, steel fibers, and these are varying as different support classes as we go through different geology. And in secondary lining, we are using unreinforced concrete with microfibers, and sometimes a combination of microfibers with steel fibers. And where we have encountered very poor geology, we are using conventional reinforcement bars and steel fibers with the concrete. With this, I'll just I would like to go to Colonel Sunny for explaining. Lieutenant Colonel Sully to explain what lies ahead for the project. Since he is the client, he would be looking after this project for a longer period of time than us, and he would be the best person to take over from me. Lieutenant Colonel Sunny, please, yeah, go ahead.
Thank you, Sandeep. Now I'll take on. After that, quite a session now. I just wrap up all the things quickly. As we all know that Shinkula is located at an altitude of 5,100 meters above the mean sea level. And schedule by working throughout the year. Now, what is happening here is if there is any delay at a particular stretch, that would have a cascading effect on the entire project, because already we are falling short of time. We don't have any time to cope up. So 4 to 5 months we are already. So that is very particular here in any project which is at a high altitude area, which is a snowbound area, and where working season is very less. To avoid any, I would say, any fatal lapse of time, it is much more relevant to stick to the time schedule very stringently, and to follow it very strongly. Second is maintaining accessibility to the project areas, especially in the winter season. Now, what is happening here in this particular project, when we are approaching towards the site, when we are at Shinkula Pass, the entire stretch from Darcha, it is 30 kilometers from Darcha to Shinkula. Now, in this 30 kilometer stretch, we have done a study from a different team altogether. We have approximately 10 to 13 avalanche sites. So what is happening is these avalanche sites are activated in the winter season. That restricts our movement towards the site or the project site itself. So that is one very major point. Now it involves heavily employment of resources and manpower, both dedicatedly, which is continuous avalanche sites to maintain the connectivity throughout the year. That is one point to note down here. The next is, since it is a high altitude area, health facility at passes is definitely a question which is there is always in mind, and it should be always there on the table, because the real asset of any organization is the workers, and if we can provide the better living condition, or I would say a safe living or a safe working environment, then it is on our part. So now in a high altitude area, as we know, the oxygen is less, so we have few issues coming up. That is, I'll highlight few of them. One is the swelling of brain, which is also known as high altitude cerebellum edema. Now it is rare, but it is fatal. Second is swelling of lungs, which is again because of lower intake of oxygen over a long period of time. That is also known as high altitude pulmonary edema. And then pre-existing medical conditions, they get aggravated once you are there in a high altitude area. So these things need to be taken in consideration. That brings me to the next, I would say, interrelated point, that is evacuation, which is mainly a descent of that particular individual from the high altitude and some oxygen. Then we can have oxygen chambers installed there. Now, what is happening is site. This is one. And then after this, we need an evacuation plan in place, so that any eventuality or any exigency, any individual planner. Now I'll cover all the points. I have the further points here in the presentation, as you can see, are under the logistics. I would take it under the logistics. The first point is now the workforce. We have around about 400 to 50 people working on, let's say, one attack point, or let's say two attack points at present, or maybe in any project which is going on. Now, managing this much of workforce at particular high altitude area involves firstly their stay. The stay is should be closely located to the work site. So we are what the speakers have brought out very clearly would be cut off for approximately 3 to 4 months in a year. So we need to have that stacking of ration in place. So even if we are planning to a practical approach, there is a requirement of heli terms of communication, and there would be many times when the weather is bad, we don't expect the heli to come, or even the rescue operations are halted because of the bad weather. So we need to be prepared for situations like this. We need the location, as we know that this is a remote location, so these problems will definitely there. Now just for the incident, when we consider Shinkula, the nearest location would be Manali, from I would say plus 10, 15 degrees Celsius to minus 30 degrees Celsius in winters. That is extreme. So we need to provide enough heating arrangements so that the workforce is comfortable, and we have provided a working environment in order to take down the maximum efficiency when we are targeting our timeline. Communication has been rightly brought out. The communication is limited to long range radio sets, which is we call it walkie talkies. As per the intra project communication is concerned, inter project communication that is being done through Inmarsats or satellite phones. There is no other way of communication for the work side for the project to the outside world. Electricity is another big challenge in these projects, as we all dependent on the gensets for complete electricity, and plus being a mechanical equipment, as rightly brought out by Sandeep, that the efficiency of any equipment lower down by 30% or maybe 40% in a high altitude area, which is almost 5,000 meters above the sea level. So that has to be taken care of. Then the redundancy part comes in. The redundancy is, again, we don't have any backup. So the generator set which is being provided for the electricity is another set of generators for the backup of the main generator sets. That is the redundancy here in this project. Here a point to note down is the less dense air does not thus beyond the efficiency to be catered in our contingencies. Then I'll move down to a few of the miscellaneous listed here. Firstly is the rescue team on ground to attend the calls immediately. What is happening is we have a heli evacuation system in place, we have a medical evacuation system in place, but the ground zero reality to attend the casualty, we require trained professionals who can find their way through thick of snow in the worst of the climates, so that the evacuation can be immediately attended. That is one. Then a proper medical setup, because if there is a delay in any heli evacuation, the patient should be addressed immediately with the bare minimum medical facilities. So these are very, I would say, resource consuming setups which would be required for any base camp to come up for a project like this coming up into a high altitude area. Then we need specialized equipments. Like in one of the photographs, I could see that all-terrain vehicle was being used. Now, what is happening is, since the entire area is like this, and for that complete year out of 12 months, almost 6 to 8 months, we'll face snow. So we require the dependency on, I would say, on the all-terrain vehicles becomes very heavy, and we should be well versed with the equipments, the drivers who are specialized to drive these equipments in a terrain or in snows like this. More dependency on tracked vehicle rather than on wheeled vehicles. So these are all points which would increase the cost and resource of anyone who is being a part of a project in a high altitude area. That is one. Then training of evacuation, that is very important, because what is happening is whatever the set of people or the set of specialists there are on ground, they need to be well versed with the situation or the eventualities which would arise in any case, so that they are anytime ready to attend all these issues and can bring out the help within themselves. Then the last point here is the specialized clothing. We need to work in a high altitude area. Now, clothing is very important because unless the people are comfortable, they won't bring the maximum efficiency. So this is again becomes very important to provide them the correct set of clothing and the equipment to work in a high altitude area where we have a lot of snow and less of oxygen around. Plus, the connectivity to the main land is difficult. So these things are very important. Sandeep, I'll request for the next slide, please. Now, as Border Road Organization is also taking care of the Atal Tunnel project, which is, as we all know, is the highest tunnel to be built at a height of 10,000 feet. And it is the longest tunnel. It holds the record for the longest tunnel at that particular height. So I'll bring down a few points from the project, the experiences which I've faced, because it itself is in the kind of a high altitude area where we had a lot of issues as far the tunnel is concerned. Next slide, please. Okay, fine. We had issues like since it is East Pir Panjal ranges in the Himalayas, when the construction was on, the shredded and fractured rock was one of the major impediments in the construction. Specialized focus has to be laid on these issues to address these particular areas. We had an issue of high overburden during this project, where approximately around 780 meters from the south portal, it needed a dedicated effort as far the designing is concerned. Then the large cross section area, north portal inaccessible for 6 months a year. This was the most challenging part because what was happening, there was 2 attack points. One of the attack points was almost defunct in winters, whereas we were only able to address the tunnel from one point, that is south portal. Then sort of squeezing happening inside throughout the tunnel, and one rock burst incident happened in the tunnel, but fortunately there was no fatal incident as far the rock burst is concerned. Next slide, please. So these are the few photographs where we can see the first photograph clearly depicts the area which has gone through a rock burst incident, and the entire area was redone again. It was repaired completely, and this took a lot of time. Basically, it took time to get the rectification done, which increased the overall time frame of the project, which was unforeseen event, contingency, not planned exactly, but then addressed well within the minimum time frame. Next slide, please. All right. There was a particular case of Sirinala fault zone, which was addressed during the construction of Rohtang Tunnel. Sirinala was a fault zone where, when the excavation phase reached fault zone, which was around 2.5 kilometers from the south portal, suddenly a lot of muck and water started gushing out of the main face to a tune of 8,000 liters per minute. The entire work was halted, and we had absolutely no idea what to do. So these are kind of the events or unforeseen event which was faced during the construction process. Then eventuality, a lot of study has gone, a lot of effort in terms of manpower and resources. Finally, we were able to over, but yes, it extended the construction period to a very large extent, which in fact has affected the entire project. Can we have next slide, please? All right. As we all know, the Rohtang Tunnel, the portals which has come up, the area also required stabilization of the south and the north portal. Now, with the tunnel coming up, the challenges faced, we are moving ahead with the Shinkula Tunnel project coming and gearing ourselves for the project, because that is going on to a level plus. Here, the height address was 3,500 meters, which gave us a little stint of what is all about working in a high altitude area. Now we are addressing the Shinkula Tunnel project, with which we are working at a level of 4,500 meters to 5,500 meters, which is extreme of any high altitude area. A lot of snow and very minimum of working period are available to us throughout the year. So it would be more challenging, and the level of difficulties would be the same nature. I would say increase exponentially. So we are planning in such a manner, and as a team, we are all giving dedicated effort and time to all these challenges, and devising ways and means to streamline each and every factor of it, so that the efficiency is the maximum, and together able to meet the targets in time. May I have the next slide, please? All right. So with this, we come to the end of the presentation, and I would like to take this opportunity to specially thank TAIym and BTSym, all the speakers and myself. We are really grateful that you have provided us with such a excellent platform, a forum where all the eminent speakers and all, I would say, prestigious listeners are there, and to share our experience with them, which would not only increase the I would say the experience all over around, but also would add up to the quality of the work which we are already trying to get out of the various teams coming together for tunneling. Thank you so much, and we are really grateful that we share this platform, and hope this presentation adds up to the experience part of everyone. And if anything comes up, we are more than eager to share our solutions on ground with anyone who requires any further details. Thank you so much.
Thanks for the very kind words, Sandeep. I mean, it was more you guys and you guys sharing your knowledge, which was beneficial. So yeah, it's definitely a great presentation, and just added on to the list of other good presentations we've had. So thanks a lot for that. And of course, thanks are in order to the remaining TAIym for actually helping both the audience and the BTSym get in touch with you guys to listen to the experience you were sharing. So we've got, I believe we've got a few questions on YouTube. So Ayush, is it fine if I read them out, or would you like to direct them towards the speakers?
Definitely, you can go ahead with this, Vivek. I will join.
Fantastic. So the first question we've got is from Chris Presidy, who asks, how beneficial was the AEM survey, and how did the models, how the models produced from the data? How were the models produced from the data? Shaz, you're on mute, I think.
Sir, see, when you are doing AEM survey, especially in the very high altitude, the maximum elevation what a helicopter like Chinook can go is 6,000 meters. And we were already, the peaks of the alignment were already around 5,500, even touching 6,000 meters. So there were certain constraints especially in AEM survey. So, and one of the very challenging thing what the pilots faced were the peaks were very steep, especially in the middle part, in some of the other projects also. So in order to get a deep penetration of 600 to 700 meters, you have to maintain that 50-meter gap of the antenna with the ground. So and in that area, the velocity of wind is very high, and in order to go in a straight line, you have to maintain a minimum speed of around 80 kilometers per hour. So if you go less than that, the wind will take helicopters away, and if you go more than that, you're not able to take that particular maintain that difference of antenna and ground. You have to like take gradually before the ridges are there, so that the gap between the antenna and the ground is difficult to get when the ridges are very steep, and especially when you have to take a turn, because you cannot climb beyond 6,000 meters. You have to take a turn, you need to get at least 2 to 3 kilometers of turning radius. That was also very difficult to get in some of the project. So altogether, what I want to say is like uh, EM survey was good. We get very good data, and we had done various studies, and we had compared that data with our other surveys what we did, like ERT and SRT down the line for a better accuracy, and we got decent results. The results was good. Even we had matched that data with our drilling points, the boreholes what we got, and altogether we, when you make a complete model, longitudinal model, it was good for the project.
Fantastic. Thanks for answering that. The next question is from Sachin, who asks, so when we speak about Himalayas, we need to factor in the vast permafrost regions there. What are the suggested methodologies to tackle these areas with respect to tunnel and foundations of bridges that may be required?
Very nice question. We do understand that being a permafrost region, we're having a very less window where we don't have snow. We need to make sure that we do maximum amount of work. I mean, the one specifically below the foundation uh, in the summers. Usually before this, all the projects that we used to do were in summers, and then we used to take break in winters and then come back in summers to do the rest of the work. But since the projects are on very swift timeline, very short timeline, very fast paced, so we have to find out the ways to work in that scenario as well. So we need to make sure uh, that we plan things in such a way that substructures are done uh, preferably in summers, and then later on building up the superstructures in winters where we can easily access. Then we have to cover the region. It has to be planned in a way that it's covered so that it doesn't get affected by snow, especially the place where we are working. And then we manage the logistics and the supply of materials around it, as I have already shared in the presentation. So this is how things can be done. I know that this is going to be a difficult task. There will be a lot more things to learn when we work in such scenarios. Um and I'm sure that this being a unique experience for India, and I think for the world as well, because I think this is probably the highest tunnel portal in the world for tunnels, which is coming up, and there are many more tunnels which are coming up higher than that. So this is going to be a unique experience. There are things that we still don't know about, which will happen when we are on site, although a proper planning and methodology will help for sure.
Yeah, I mean, the way you guys explained it did appear to be quite the challenge, if not one of the most challenging projects we've seen in the industry for a long time. I'm just being mindful of the time here because we've already reached the 2:30 mark here in the UK. So I might just draw the Q&A session to a close here. I know we've missed a few questions, but it's just to accommodate the the amount of time people can spend listening to a lecture, especially during the middle of a working day. So I'd once again like to thank all three of you for sharing your experience with us, and hopefully we will have you again in the future, either midway through construction or once the construction project is over, to find out more details about the project. And also, thanking Ayush again for coordinating all of this from the Indian side. So, Ayush, would you like to add a few words as well?
Yes, Vivek, I want to thank Lieutenant Colonel Sunny, Sandeep, and Ahmed for this wonderful and challenging presentation, showing us the challenges in the Himalayan region. Here, I would also like to thank all the listeners who joined from India and from the Britain. And lastly, I would like to thank you, George, and the whole BTSYM for all the efforts made for making this presentation success. Uh, I would just like to request Devik to share the YTC poster so that we can brief our listeners about the Young Tunneler Conference, which is going to be held in Mumbai on 25th of June this year. We are keeping our finger crossed that COVID will not impact this conference again as it was planned in January. So we have requested everybody for their abstract and the presentation. All the details we will share via mail. So this is our poster for this YTC 2022, which is going to be held on 25th of June 2022 in Mumbai. The venue details will share via mail, and all the details regarding the presentation and abstract will be shared via mail. So that is from my end. Vivek, over to you.
Fantastic. I've just recently returned back from India, so I'm not really sure if I can attend it, Ayush, but I would have loved to attend it. Hopefully next year.
We will wait for you, and we'll wait for our friends from Britain, those who can join this conference.
Fantastic. Well, then talking about conferences, we've got a conference coming up as well. So the BTSYM conference is planned for the 20th of May, so hardly any time remaining. It will take place, it's a day-long event, it will take place at the Institution of Civil Engineers in Westminster in London. The bookings are now open. It's free for any paid BTSYM member to attend, and it's £60 for non-members. But remember, a BTSYM membership is only £42. So please do think about joining us at the conference, and we shall be announcing the presenters lineup next week, and we've got some really fascinating presentations in mind for the conference. In line with training and knowledge, there's also the BTS Tunnel Design and Construction course, which is a week-long course at University of Warwick, scheduled to take place in July. The bookings are now open. You can find more information about the detailed program on the BTS website. And again, bookings are open for anyone, whether they are in UK or even overseas. It does attract a good amount of people from overseas. So if you are in your early career, if you want to know more about soft ground tunneling, please do consider attending the course. So those were the only two announcements from my side. So we can, I think, bring the proceedings to a close. But once again, thanking our speakers for today for sharing their knowledge, and again, thanking Ayush and the rest of TAIym for collaborating with us.